No, you can't do that. It doesn't work quite so easily. So, unfortunately, to solve this, you would probably think first u substitution, right? You'd probably think maybe this is your u part, and then you got to think of what your u prime is, which would be e to the x. So we're missing that part. Plus, we have an extra x term in here. We're not really sure what to do with it. Typically, use integration by parts when you're multiplying things together. Or if you're dividing things, technically that's multiplication, right? You can split it up and it'd still be multiplication. So, generally, it's kind of like going backwards from the product rule. Product rule, you take the derivative of two things multiplied. You do, u prime b and then b prime u. We'll do a little thing on this. But the general idea of integration by parts is this. If I'm integrating something of u dv, which has always been kind of a, what's happening? My letters aren't matching up, right? I've got a u here. I'm taking it with respect to v, though. So I've got a couple different functions, a couple different versions that I'm doing. Okay? What this is going to integrate to, it's going to integrate to uv minus the integration of v du. Now, the weird part about this is, I know, where'd that go from? First off, we got a u and a v. This is basically a u substitution problem. Okay, we have to identify what we think our u's are going to be, what our v's are going to be, what our dv's are going to be, what our du's are going to be. We have to identify a whole bunch of stuff when we do integration by parts. Okay, but if I want to integrate something that I think looks kind of simple, basically multiplying a couple things together, I'm going to figure out what u and v are, multiply them together, and then subtract the integral with a little switch going on here. Okay, and it's going to make a lot more sense after I'm all done doing a quick example problem here, hopefully. So now, this little generalized version here, where does that come from? Right? Okay, so real quick, tune me out for about 30 seconds, but don't talk. So let's say I have u times v, right? Two things that I have, and I want to take the derivative of that guy. That's the derivative of x. So take the derivative with respect to x of u times v. So what's that going to turn into? It's been a long time since we've done this, but
u prime v plus v prime.
Okay, everybody okay with that? Now I'm just going to clean it up just a little bit. uv, and that's going to equal, this is going to be v, and then du. U prime is basically du. Okay, I think we're okay with that. Plus, this is going to be u dv. Okay? Now, assuming u and v are both continuous functions and blah, 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 and all that fun stuff that makes everything work nicely, let's integrate everything in there. Okay, I can integrate over a plus sign. I'm okay with that. I can integrate both sides, doing the same thing to both sides. So integrate this, and integrate this. Okay? So if I integrate this, the derivative of u times v, right, what's this going to turn into? uv. Okay? So it's going to turn into uv equals the integration of v du. We still don't know how to do that. Plus the integration of u dv. And one last little thing. So if I want to find the integral of u dv, some little funky thing going on here, all I have to do is move this guy on the other side. So it's going to be uv minus the integral of v du is going to equal the integral of u dv. Okay, so pretty quick proof of at least why it works. That doesn't tell you anything about how to actually do integration by parts, but that's where that comes from. Okay, it's basically just kind of a tweaked version of the product.
I didn't get that first part where you said
From here.
the very first u prime v plus equal to u.
Product rule of these two guys. I got to multiply when I'm taking the derivative of two things multiplied. I have to take the derivative of one times the other plus the derivative of the other times the first one. It's kind of like the quotient rule, but it was subtract. Just a basic product rule for that. Okay. So if I were taking the derivative of x squared cosine of x, right? I'd have to take the derivative of this, multiply by that, plus the derivative of this, multiply by that. Okay. So that's what that u prime v prime d is. What do you got?
So why did we decide to take v to u instead of u to v?
And honestly, it doesn't matter. It doesn't matter one bit. You could have that, because all of this is just letters switched around, right? But the concept is still the same. You can still flip the letters to get to the other side, still doing the same thing. Okay? All right, let's get back to our problem here. Our problem is going to be this. Now, the actual integration by parts itself is not hard. We know how to integrate everything that we can integrate as far as functions go. Okay? That's just the style of how we do it. The hard part about any of these integration by parts is identifying what is going to be what. That's what I think is going to be the toughest part. Okay? So let me just give myself a little room here. I'm going to go the integral of, this is going to be u dv. It's going to equal uv minus integral of v dv. Okay, first thing I'm going to do is figure out what my u's and dv's are. Okay, I've got a u and a dv here for my initial integral. Okay, so u and dv are what I want to identify first. So I'm going to say u is something, and I'm going to say dv is something. Okay, that's going to be the first part, is identifying which part you're talking about, which part you're calling what. Now at the beginning, there's not really, you guys don't have any strategies for what to pick. So at the beginning, it might be a little bit like a leap of faith, but just so you see how this first one works, okay? So for this first one, I'm going to say I'm going to say u is going to be the x value. So I'm going to say that this guy right here is going to be my u value, okay? So I'm going to say u equals x for this guy. I'm going to say all this stuff right here is going to be my dv part, okay? So that's my dv part. It's going to be e to the x dx. Okay, now we need 4 things here to make all this stuff work, right? We have a u and a dv, we have a u and a v, and we have a v and a du. Okay, so basically we've got a uv, du, dv. We have 4 things we need. Once you pick your first 2, find your other ones now. Find out what your du is going to be. Now your du is going to depend on what you pick for your u. It's going to be 1 dx, right? So it's just going to be a dx, 1 dx. Okay, your dv you picked, e to the x dx, or I picked, sorry. So your v value, what's your v going to be? E to the x. Just integrate, right? So we're going to integrate that to get e to the x. Now once you have those 4 parts there, you can just plug it right into that integration by parts now, okay? It says if you want to integrate your first answer, your first question here, multiply u and v together, okay? So u times v is going to be x times e to the x. So it's going to be x times e to the x.
That's what?
Subtract, that's this part, u times v, u is x, v is e to the x, so it's u times v. Subtract, now I've got to subtract the integral, so I'm going to subtract the integral, v du. Okay, we'll look at your little sheet here. You got u, v is e to the x, and then du is dx. So this guy's going to be a dx right now.
Quick question.
Okay, quick answer.
When you have u equals x and you have du equals dx.
Yes.
But why isn't it x dx or something?
Because what's the derivative of x?
1.
So it's 1 dx. But that writing that 1's overkill.
Okay, I think I just got confused with the u's. And okay, so you take respect to another variable or something.
Yeah, I'm taking the derivative with respect to x on this stuff right. Yep. All right, so now I've got it into this nice little function that I can do now, right? I've got x e to the x minus, I've got the integral of the e to the x dx, right? Well, what's the integral of that? What happens when you integrate? E to the x, okay? So we got e to the x, add your constant, you're done.
Yeah, that sounds like a awesome.
That was pure talent.
Okay? Now, the nice part about this is, check your answer real quick, right? You can always take the derivative of this and make sure that it equals your original quantity, right? Or make sure it equals your original question. So if you do this, you have to do the product rule for this, right? If you were to, I'm just going to take the derivative from here, right? So from here on, it's the d over dx, okay? That's what I'm doing from here on. Okay? So product rule for this, the derivative of x is 1, multiply by e to the x, right? And then plus the derivative of the second one, e to the x multiplied by the first one, which is x e to the x, minus the derivative of the e to the x is e to the x. Derivative of a constant goes away. E to the x's cancel each other out, so I get x e to the x, which is what I start with. Okay?
Oh, yeah.
So you can take the derivative of that to get back to your original integration problem. Okay? All right. We okay? Now, the toughest part about all of this, is what the heck do you pick for your u and your d? That's going to be the toughest part for you guys to see. And to be honest with you, there's not like a great, always do this. There's not a great way to do it. You just have to kind of guess. Typically, what you want to look for is whatever you pick for your u, you want your derivative to be an easier problem. You want it to break it down to an easier problem. Okay? If you want to also pick your dv, you want to pick something you can integrate pretty easily, right? It might be a more complicated piece of the equation, but it's something you can integrate and hopefully it works out. Yeah, what do you
So does this show up with trigs?
This does. We're going to do one with trig. Yep.
So
Trigonometric function. Yeah.
technically, would it even matter which one you picked as the u?
Good question. Let's do that same problem, but let's pick the other way. Okay? Because it might not matter. Some is definitely going to matter. Some you're not. Some you won't have a choice. Okay, so we're going to do the same exact thing. Okay, and I'm just going to. You guys probably have it on your board, but I think it helps just to have it written. So it's u dv equals uv minus integral of v du. Okay, so that's kind of our general pattern that's going on here. Basically, you have opposite variables on all of them. These have to have the d's with them because they're integrated. Okay. All right. So let's say we pick the other way. Okay. Let's say we pick the other way, which I don't know if I would recommend. We'll see what happens when we get there. Okay. So if we were to pick one, let's say we picked our u and our dv. We have to pick our u and dv. That's always what you at least start by what you're guessing. Okay. That's the first two on your first integral. That's why you picked those two. Okay. So let's say we got those backwards, right? Let's say we said u was e to the x, and then our dv is going to be an x dx. okay, which is kind of weird, but I made this my u, and I made this part and this part my dv.
Why can't you just e to the x?
Because if I put e to the x dx here, and I take the derivative of that guy, I'm going to have another dx there, right? The dx has got to go over with this guy no matter what. Because you're going to integrate dv to get to v, right? And so you've got to have a dx with it. Yeah, you have to have that part over there. You don't want to have an extra dx over here, that'd be weird. You'd be taking the derivative of something with the derivative symbol, that'd just be funny. Wormhole. World blow up. So as I look at this, just pick what I have, right? I have my du, that's what I want to find next. Okay, so what's your du for this one? E to the x dx. Okay, so e to the x dx, then you find your v. V is the integration of that, which is x squared over 2, right? So x squared over 2.
I don't like fractions.
Your integration just got tougher, right? And your derivative didn't really help you. But let's go ahead and plug it in and see what we get. So it says u times v, so it would be x squared over 2 multiplied by e to the x. That'd be my u times v. Subtract the integral of v du. Okay, so I've got a v, and then du is going to be this guy right here. So I'm going to have x squared over 2 e to the x dx.
So that is
I made that way harder, right?
Yeah.
I made that grosser. Now, sometimes you still might have another thing. We'll talk about that tomorrow. But for now, if it gets gross like that, you don't want to pick that one, okay? So that kind of tells you which one to pick. Now you want to switch it around, pick the other.
Can you do that again?
Yeah, what you have to do
Tomorrow. Tomorrow. Yep. Some you have. Some you don't have.
It's like a chain rule with it.
It's, yeah.
Would it still work?
If you know certain things.
The problem is, it'd be gross. You would actually eventually get to the same answer. You would just spend way more time on it. You would have to do 3 or 4 by parts if you pick the wrong ones, right? Which is kind of gross. So we don't want. We want to try to avoid that.
Is there like a metal detector, but it's like a math detector?
There's no detector, unfortunately. Although sometimes like this one, your hands will be tied on this one. You won't really have too much of a choice on this one.
Would u be x squared?
Maybe.
Yay!
You're wrong, but maybe. Dang it. You had a 50-50 shot at least.
He's like, well, I'm not going to this time.
I give. Okay, so there's our by parts. It's always good to write it a couple times. It'll stick in your brain a little better.
Right.
Okay, now identify your first integral. Identify what your u and what your dv is. Okay, so we want to figure out what our u is and figure out what our dv is. Those are the big things I want to look for. Okay, what's up?
How do you?
Okay. I agree.
Okay. Why didn't you?
Whoa, what's going on? I have a question.
Stuff you guys today.
Okay, so you had uv, the derivative of uv.
What?
Okay, continue with your question.
Anyways,
Continue. It's just a phone. It's not a big
the
deal.
integration of v du plus the integration of u dv. Why did you subtract one on the other side, not the other? Like,
It doesn't matter.
oh, it doesn't.
Yep, you could have gone the other way, but generally it'd always be this, because usually we always think of some kind of u substitution. So usually we'll have some kind of u as our basic letter to start with. So that's the only reason. Okay, kind of the question that you asked. You could get it backwards if you want. It doesn't really matter. Okay. All right. So now try to identify what you think is your u and what you think is your dv. Okay. Now real quick, I'm guessing a lot of you guys would have picked this to begin with. Just guessing. Okay. Now the problem with this is what's v going to be? That's the derivative of the natural log, right? What's the integration of the natural log?
Nothing. 0, 1, 4.
No good. Oh, we don't know how to do that one yet, right? We don't know how to integrate the natural log yet. Yeah, of course. We'll be able to do it by the end of the day.
Really?
Really?
Potentially. Okay? So I probably wouldn't pick this one. Okay? Probably wouldn't pick natural log. Let's flip them around now. Okay? So I'm going to say this guy's going to equal the natural log of x, and this guy's going to be x squared dx. Go ahead and get your du and your v real quick. Okay? Maybe try to set it up into the template.
So now we have a fraction.
We have lots of fractions.
Got it. Don't worry about your plus C here, guys. Don't worry about that. Because it'll get wrapped up into the plus C at the very end, okay? So you don't have to be concerned about that first one.
I
Okay.
never even thought of that.
I'm too smart. That's what I got. Is that right?
Except for just kidding, cancel it.
Okay, so this one's a little confused. Sometimes you have to simplify the integral first, but hopefully you're kind of following my flow here. U derivative of that is going to be 1 over x, right? Derivative of natural log, okay? Integrate x squared, it's going to be x cubed over 3. And now we just kind of plug it into that formula, okay? It's formulaic base. So we have u times v, multiply these two, u and v, and then subtract the integral of v du. So we got to put this v back in there again, and then the du. So we're going to put these two guys together, okay? So we have the v here, and then we have the du went right here. A little bit of simplifying on this guy right now. So we have x to the third natural log of x over 3. Not going to change that one. Subtract out here, I'm going to cancel out one of those, so it's going to be x squared. Okay, we integrate that guy, so it's going to be x to the third over 9.
Is that how we have to do it?
And that's it.
You don't want to factor out x over 3.
They might force factor something. They might force factor an x to the third. You know how they're kind of evil and they force factor something like that out?
Yeah.
And then it'd be, 3 natural log. They might even be super evil. No, wait a second.
It'd be 3 out of 1, right? Yeah.
They might even be evil and do something like that. Potentially.
How did you get?
Not that it really matters. Yeah.
How did you get from?
Here, here.
Yeah.
Here, I didn't change that. Right? So all I did was do this integral right here. Okay? I reduced an x first, which is x squared over 3, and then power rule. So x to the third over another 3, which has been 9 on the bottom. Okay? So, we're feeling okay so far? Okay, let's have you guys try one real quick here. Give this one a shot. Then we'll do 2 more real quick and be good.
Do you want including this one?
After.
So does this really matter?
I think it matters.
This is new stuff for you guys, isn't it?
Yeah.
No.
They don't know how to do it.
They're feeling this.
No, we know the cheater ways. We know how to integrate them.
Watch their grade go.
You know how to integrate natural log of x?
Oh, yeah. Yeah, I was just trying to throw you off.
Okay, fair enough.
I'll remember when you explain it to us.
Maybe. Well,
Whatever, just remember.
you can't because you have to do it by heart to do it. So.
Yeah, but we already know how to do this.
You've never done this.
So I have a quick test for you. Is it better to have smaller number for the U or the DV? Like,
Technically, usually you want to pick the more complicated version for the DB. Usually, not always the case, but usually. So the 2 big things you'll kind of look for is more complicated, more complex ones for the DB. Hopefully it integrates nice. And then the one that looks a little simpler, you can just review, and then hopefully when you take the derivative, it gets even simpler.
okay. So it's just
Just
Because we already did this.
Hey, me too. Oh my gosh. We're twinsies. Really? Sorry.
So hopefully you guys did something like that for your U's and your DV's. Your U and DV are kind of the critical things to pick. As soon as you pick those correctly, you'll be good to go. And you really have almost a 50-50 shot, usually. You kind of identify what's going to do what. Okay, so go ahead and throw those into that generic formula. It's U and V. So we're going to go negative x cosine of x.
So you never use DV, right?
So you actually never use DV in this. You're exactly right.
Yeah.
It's part of the original integral. It's part of the original integral just for your setup. And you use it basically to find out what your V is. But yeah, you're right. You never use the DV on it. Okay, so we've got negative x cosine of x. Take away. Looks like it's going to be v du. So it's going to be v du. These two guys right here. So there's another negative sign right there. I'm going to make this a plus. Cosine of x dx. And integrate. So negative x cosine of x. And then there's going to be plus, looks like the sine of x. Plus your constant. Good. Okay.
That would be nice.
Okay.
If you get the
Once you get the u's and v's, it's just plug it into that integration formula and figure it out. Okay. All right. Go ahead and integrate the natural log of x real quick.
Okay.
Integrate natural log of x. It's not 1 over x.
Are you sure?
Is x over 1?
For sure.
I know, I have to fix just.
Okay, now guys, the super evil part about tonight's homework is not only are they going to make you do integration by parts, but they're going to mix in some that you don't need to do integration by parts on. Some just regular u substitution. So, be cautious tonight. It might behoove you, well, I looked up how to spell that word the other day. Behoove you to check u substitution first. It depends which country you're in. For us, I think it's B-E-H-O-O-V-E.
Wait, wouldn't that just be 1 over x?
The derivative is 1 over x.
Oh, so the 1.
So let's integrate this by parts. Okay? Let's integrate this by parts.
It's just ln of x.
Yes.
It's 1 over x. I think you just put it like.
U equals something.
Really?
dv equals something.
Wait, I don't get why it can't just be 1 over x.
Because that's the derivative of
U
it.
equals ln of x. How about u?
The derivative of natural log is 1 over x.
Wait, but there's only
We can integrate to get into a natural log, but we don't know how to integrate a natural log yet. We haven't done this yet. This is brand new.
But you don't have 2 terms.
But we don't have 2 terms. Big statement of the day. Okay.
Would you use dx for
So as I look at this, first off, if I knew how to integrate natural log of x, wouldn't I just do it right at the beginning? I wouldn't even do integration by parts, right? So if you can do that, why would you put natural log of x in the dv spot? Let me ask you that. Okay? So that kind of locks you in a little bit as far as which way to do it. Okay? You probably aren't going to put a natural log over in the dv because we don't know how to integrate yet. We don't know what the nice answer is for. So let's go ahead and put it in our natural log of x. Let's set it equal to u. Okay, so what's left over for the dv? dx. Yes, all there is a dx, okay? Technically there's a 1 in front here if you want to put a 1 with it, but it's overkill, okay? So the dx is literally that's the only part for a dv, okay? So just because it's not 2 things multiplied doesn't mean we can't do it by parts, okay? So now we can just run from here. We just have our du. We're taking the derivative of natural log of x, which everybody
1 over x.
knows that one. Yay. Okay, so du is 1 over x. That means that your v is going to be just x, right? So integrate that now. We're going to plug it into that basic formula, which is uv. So it's going to be x natural log of x.
OMG.
Take away the integral of v du. V is x.
Ooh.
Du. Oh, did I miss something? I missed a dx here. Sorry, guys. So v du. So I'm going to have an x, and then I'm going to have multiplied by a 1 over x dx.
OMG.
So x natural log of x. Subtract the integral of 1, which is
X. Woo. Is that like an identity kind of thing?
Plus.
Sort of?
It could be an identity. You could memorize that if you want. If you ever run into across the integral of natural log of x, it's x natural log of x minus x. You might even factor an x out there, x and then natural log of x minus 1. Some people will write it that way too. It just depends on which book you use,
I don't
okay?
get how you got the x.
Because if I multiply, if this reduced to 1, Integration of 1 bumps up the power to x. Anytime you integrate dx, it goes to x. Okay, takes the d up. Okay, so you can write it in a couple different versions, a couple different fashions, and life is good. All right, let's do one last one. Okay, now before you guys start guessing, you can take the derivative of arcsine, but you can't integrate arcsine yet. So, the integration of natural log of x is not 1 over x. Doesn't work that way. Wasn't this on the derivative of it was?
No, it wasn't. Are you sure?
Feel free, if you don't believe me on anything of this stuff, feel free to open up your books to the front page right there, and it lists out what they call the basic integration formulas. If you notice, none of this is on there. Okay, so we're past the basic ones that are on there. Okay,
That's so weird because
we're in intermediate. So.
Are you missing an X or is that just the same?
I am missing an x because yeah, sorry.
Okay, sine is dx.
Sorry. Yeah, arcsine of dx. Yeah.
Yeah.
Sorry, I said that, but you don't usually say that x if you're, well, at least I don't. But
Yeah, I know. Only the cool kids.
only the cool kids say it.
What?
Does that mean we have to say
That'd be cool. Okay, last one. Okay, so we have our u and our dv. Now, once again, kind of a hint here. If you don't know how to integrate that, well, you probably shouldn't put it in the dv spot. Okay, that'd probably be a bad idea. Okay, because if you could, you just do it right at the beginning. So don't put it there. We're gonna put your arcsine here. You put the arc on one spot, put the sine on. No, it doesn't matter. So arcsine of x. And then your dv on this one is just going to be another dx, same as the last one. Okay, only have one term on the inside there. Okay, now we have our u prime or our du. Okay, du is going to be the derivative of arcsine.
Radical. 1, 2, minus.
I still have not memorized those.
That's all right. There's 3 of them. Got to get those.
Just 3?
Yep.
Range.
Yeah.
Because
That's just negative. Same thing. Okay, and then your v is x. Okay, so your v is x. Awesome.
Oh, yeah.
Wait, don't you need dx?
I do. Thank you. Thank you. I always forget that one dx. Okay, so now do your integration by parts. It's uv, so it's going to be x arc sine of x. X arc sine of x. Subtract the integral of v du. So we need an x multiplied by this stuff. So it's going to be an x over square root of 1 minus x squared dx.
That's easy.
That actually is pretty doable. I know you guys think it looks kind of hard, but it's pretty doable. Think about u substitution now in this part. It's no longer by parts. Think about u substitution. Okay? Think about what you would make u equal.
Oh, I got it.
Is everybody okay with the x over the square where I got this part from? Because I multiplied these two, and the x I just, when you multiply those, I just put the x on the top there. Okay? So now you just do u substitution here. Okay? So for this u substitution, you would make the denominator your u, or I'm sorry, the stuff inside the radical is your u. So that means that your du, or your u prime is on the top here. I need a negative 2 on the top here. So I would put a negative 2 on the top here, and then put a plus 1/2 on the front. Negative 1/2, but it was already negative, so it ended up being a positive 1/2. And now do your u substitution on this guy right here. Okay, so we're going to have x arc sine of x. I'll try not to skip too many steps here. 1/2 integral of, if I switch this to my u's now, it's going to be this, all this stuff right here is going to be my du. And so it's going to be a du over the square root of u. So we're going to integrate this guy. Okay, so we integrate 1 over square root of u, it's u to the negative 1/2 power. So we're going to bulk it by power, so it's going to be u to the positive 1/2. With a 2 in the front, 2 over 1 in the front. Everybody okay with that?
Yeah.
Okay, because it's u to the negative 1/2 here, up by power, reciprocate the front of it. I already have a 1/2 in the front, plus x arc sine of x. Okay, 2's cancel, so you get x arc sine of x, and then those cancel so that it's plus u to the 1/2, plug it back in your u, so it's going to be the square root of 1 minus x squared. Okay.
Gosh, you're teaching us how to have it.
I am teaching you bad habit. I left out a DX, I left out a plus C. All those are little dumb points that they will ding you for on that. Take a test.
Really? How much points though, honestly?
Not much.
I was gonna say, I was
many?
like,
Not much.
the actual answer has to be worth something.
It could be the difference between a 2 and a 3.
I've already used it.
D.
And you say sometimes we won't have to.